On yesterday, you added and subtracted polynomials. Today, we're going to multiply polynomials. Now remember, since we're multiplying, our multiplication rules are going to come into play. There are two methods when multiplying polynomials. One is using algebra tiles, and the other one is the distribution method. If you remember with algebra tiles, we covered them yesterday. For 1, you use a square. -1, you use a small square shaded. A long rectangle for the x bar. A long shaded rectangle for -x. A large square for x squared. And a large shaded square for -x. Distribution method. You multiply the number on the outside of the parentheses by what's inside. So 4 times x would be 4x, and 4 times -12 would be -48. Oh, sorry, I didn't know you didn't see that. Let me scoot that up. There you go. Now we're going to look at two problems down at the two problems at the bottom, and we're going to do both methods. We're going to solve using algebra tiles on the first one, same problem, and then we're going to look at it solving using multiplication. With algebra tiles, so the outside has an x, so we're going to draw an x bar on the outside. Inside the parentheses is an x. We're going to draw a flat one, and then -4, so we have 4 of the negative squares, and they're shaded because it's negative. And we're using what we call a product map to multiply. If you remember back in elementary when you learned how to multiply, numbers, you use the multiplication table. So this is kind of similar to that. So we're going to do x times x. And so x times x, if you remember, when multiplying, you add the exponents. And so that's x1, x1, and that's going to be x squared. And you kind of know what it is because whatever it is, it's going to fill in this side to this side, so those corners will fill in and become one. Ooh, what's that, a gnat? Then here, multiply x times -1, and that's going to be -x. X times this -1 is going to be -x, and so forth. And so your answer is whatever is on the inside, you collect like terms. So we have x squared, and there are 4 of the negative x's. Got it? If we do that same problem using distribution, we distribute an x times x in the first one, and then x times -4x. -4. Remember, same base, add the exponents. So that's x squared minus 4x. So this is how you solve the problem using distribution. And above that, that's how we solve the same problem using algebra tiles. Okay. Let's try this one. We have 2x, so we have 2 of the x bars, and then we have inside the parentheses x and then a +2. So we multiply x times x, and remember it fills in that space, so that's basically x squared. X times this x down here is going to be another x squared. Then we have to do this x on the side times 1 at the top, and it's going to be 1x. X times 1 is 1x. X times 1 is 1x, and 1 times x is 1x. And so basically we're multiplying everything on the outside by the top, and it fills in that product map. So now collect like terms. How many x squareds do we have? Correct, we have 2. And how many x's do we have? Yes, there are a total of 4 x's, and that is our answer. Now we're looking at that same problem using distribution. 2x times x is 2x squared. 2x times 2 is a positive 4x. Remember, when you multiply and times those first terms, it's basically saying 2x times x, same base. We added those exponents, and that's how we got 2. And then we added it to 2x times 2. Got it? Let's flip the page. Try number 4 on your own. Using the algebra trials, try number 4. Okay, what you should have got was you should have drew a negative x, 2 of the negative x bars, and a 1. And your answer, you should have had 2x squared. And then this times this, negative x times 1, you got negative x. Oh, these two should have been shaded. My apologies, that should be negative 2x squared. It's negative 2x squared. Oh, no, it's not. Oh, ignore me, sorry. A negative times a negative is a positive. A negative times a negative is a positive. So that should not be negative 2x. I had it right the first time. That's a positive 2x squared. I don't know why I went back and changed it. A negative times a positive. This one's negative x. So the answer is just 2x squared minus x. Now we look at that same problem, and you should have distributed this times this. Negative times negative is a positive 2x squared. And out here you got a negative x. And now we're going to stray away from the algebra tiles. I'm sure you don't like them, but you need to know how to do them. And we're going to do all the rest of the examples just using regular distribution method. So let's look at number 5. We distribute negative 4x times 5x, and we get negative 20x squared, negative 4x times 2, and get negative 8x. Got it? Okay, let's look at number 6. Positive 4m cubed times 5m squared. Remember, same base. What are we doing to the exponents? Adding them. So we're adding the 3 and the 5. The coefficients you multiply like normal, so that's 20m to the 5th. If we wrote it out, that basically be 4 times 5. And on the m's, you would add 3 plus 2. Got it? Then we distribute to the outside term. That's 4m cubed times 2m. It's basically saying 4 times 2. And on the m's, we're adding 3 plus 1. So that should be plus 8m to the 4th power. Cannot add any of these terms that we've done so far because none of them are alike. None of them are alike. Everybody got it? Okay, let's look at fraction. Same concept. We distribute 1/3 x times x, so that's going to be 1/3 x squared. Some of you prefer to write yours on top, so it could be x squared over 3. Still the same answer. Then we distribute out here, and we have 1/3 x times negative 27. Remember, basically that's saying 1 times 27, which is negative 27, and then divided by 3, that's going to be negative 9x. Got it? Okay, Now we're distributing this one. Take it step by step so you don't mess up. 4/5 times 9. 4 times 9 is 36 divided by 5. Then we have the x squared times the xy, same base we add, so that's going to be x to the third y. Then we distribute to the next term, 4/5 times 5/4. And basically 4 times 5 is 20, 5 times 4 is 20, 20 over 20 is what? 1. Then we have x squared and x. Same base, add those exponents, we get x to the third. Is it necessary to write that 1? No, it's not. Then the last one we distribute to the last term. And we get 4/5 times negative 30. 4 times negative 30 is negative 20. Then we take negative 20 and we divide by 5. And that's negative 24. And then that's just x squared and y. And so there's our final answer. None of those terms, oh sorry, thought you could see it. None of those terms are alike, so they're just written and left like that. Got it? Okay. Let's look at the back. We're going to skip the top, and hey, these examples are the same on the back. Oh, did I copy the wrong page? I sure did copy the wrong page. Man, I just messed up 152 copies. Okay, let's go to that problem at the very bottom. And we're just distributing. This one says to solve. Why does it solve? Because we have an equal sign. And so we have 3x distributed to the outer plus 15 minus 6 equals 18. Combine like terms. It's going to be 3x plus 9 equals 18. Subtract 9, 3x equals 9 divided by 3. And our answer is x equals 3. And that pretty much sums up multiplying polynomials. Your assignment for today is handout number 1. Go ahead and begin.